Okay. Welcome to another fun session with the Portland Python Pirates. Uh, Usually I have an intro slide that has our logo and stuff, but this is my slide deck. I've done this talk in other settings, but I'm going to do it. I've never done it for my meetup, and I was like, it's my presentation. So let's do it here. I'm just going to kick off something cool that we're going to get started. This presentation is called, Get Your Head in the Cloud. And we're going to be discussing kind of the ins and outs of what the cloud is, what the cloud is not, and then also giving some demonstrations of different scenarios where it might be useful to a business or developers or whatever. I'm not going to be doing a hands-on demonstration. I usually do that during this presentation, and the reason for that is that this is actually leading into a three-part series that we will be doing on how you can launch your Python applications on Google Cloud Platform. So there's different ways that you can do that, all range in difficulty and complexity. So we'll be showing you the how and why of doing it one way over the other. And we'll talk more about that. So, forgot about that picture. Again, we're going to explain the cloud. We're going to show the implications, like what did this do? What does this do for developers, right? Like, so the cloud is actually, pretty old news at this point, but is just now being well, I say now, within the past few years, has been growing at an exponential rate, we'll say. That's an overused term and not necessarily always used in the right scenario. If you're a math person, you'll know that. But nevertheless, has been growing quite fast. And we'll show implications for companies, like how is it helping companies? Again, I just said it, how is it helping developers? But the other thing I want to cover is certifications, right? So you hear a lot about cloud certifications. And I want to show you or explain to you the reason why a certification in this case actually could help you a lot in terms of getting a job or leveling up or whatever the case may be. So we're going to take a look at certifications, and that's going to be a definite topic that I want to discuss and take any questions, because I have gotten certified. I'm currently getting recertified and getting new certifications in the cloud. So I'll show you the how and why I chose to do it and why you might want to as well. And again, a Q&A. The end will be saved for any questions that maybe don't relate directly to topics that we're covering, or like you think of it right at the end. But feel free to drop in chat or jump on the mic and just say, hey, what is this or what is that? Ask your questions during as well. Okay, let's see. And you can use the raise hand thing. Just click that, and I'll keep an eye out for it. Make sure that we get your question answered. All right, so we got a few things to cover, so let's get into it. We'll start. What is the cloud, right? So a lot of you know that I'm a self-taught programmer and got into this data science thing, a while back. And when I first started, I had no idea what the cloud was. Like, I literally just thought information might be just flying above our heads, which it sort of is, right? But nevertheless, like, I thought they had somehow figured out to store info like around here somewhere, right? And I didn't have any idea. And as with anything, it took a lot of reading and a lot of researching and learning. So I'm gonna share some of that knowledge with you, and maybe hopefully introduce you to some things that you hadn't thought about before, right, in terms of the cloud. So what we're gonna do is we're gonna start with SaaS, right? So software as a service. You may have heard SaaS. You've heard lots of these kind of, I'll just say it, the ASS acronyms, right? Like the IaaS or all this stuff. And we'll go over some of those. But we're gonna start with SaaS. And so software as a service are things that you can just use, right? Things like Google Drive, Dropbox, Slack, all of these things are hosted in a cloud environment, right? And things like Stadia, right? Like cloud gaming was a big thing, even though it was kind of a fail on Google's part, but whatever. Stadia, nonetheless, is this idea of you playing, and the whole cloud really is you using other people's hardware so that you don't have to foot the bill for it, right? And we'll talk more about that later. But this is software as a service. So applications that you can directly use, whether for free or as for a subscription, right? With a subscription or whatever. So you could probably think of lots and lots more examples of this. Okay, so that's software as a service, right? So when we talk about the cloud in terms of businesses, right? So there's kind of 3 stages to businesses being in the cloud. The first one is on-prem. So what this is not in the cloud. This is exactly what it sounds like. What they're doing is they're hosting their hardware, right? All of their servers that they're using. And for those of you that are new to that, servers are literally just computers. So whenever you hear the word server, don't think of anything but just a computer, right? Usually headless, and by headless we mean it doesn't have a monitor attached to it, any kind of user interface, right? And so what you see here is that clients will connect to the internet, right? And through that will connect directly to some server, and that server lives at the company somewhere or in an offsite data center, but nevertheless is seen as being part of the company, right? And usually when we say on-prem, it's like on-prem, right? They have their server farms. You think of like an Intel or some of these larger companies, they'll oftentimes have large server warehouses where they're, and they do this due to like privacy type issues, like security type issues. If you're dealing with sensitive data, I worked at a company that did worked in healthcare, and PHI, protected health information, is something that is very, very sensitive, right? Lots of sensitive data with that. So there's lots of measures that you have to take. And so in healthcare, there has been a lot of hesitancy, and we'll maybe touch on this a little later, but a lot of hesitancy to use the cloud because of that, because moving data from your company up to someone else's servers is scary, because if some data gets leaked, it's on you, okay? And that's a potential risk for companies, okay? So I mentioned on-prem, right? So they have their servers at the business. We also have colo data centers, which is a very, very, very popular way. So what happened was, companies grew and they couldn't scale, right? I always use the analogy, if you've seen Silicon Valley, right? They start in their house in San Jose, and that server's like sitting in their garage and it bursts into flames and it's crazy, and they need to scale up, right? But they can't scale up in their garage, right? They need something bigger. But they also don't have the capital to buy the hardware to scale up to the level that they need. So there's giant warehouses, data centers, where companies can actually rent out server space, rack space, right? And sometimes they can rent out servers from the company, but oftentimes they're all racking their own servers. So I misspoke when I said, maybe they don't have the capital for the hardware itself. They just don't have the space to rack them, stack them and rack them at their company. So what they'll do is they'll rent out space / servers, could be at a colo data center. So once they've outgrown their space, they move into these data centers, and those computers, even though they're in a different data center, are seen as part of the network back at the business, right? So that's really interesting, is that you kind of have this virtual private network where, even though the servers are not physically in the same place, and this will carry on to the cloud, so keep this concept in mind, even though they're not physically in the same place, due to some networking magic, right, everything is seen as it doesn't care where the location is, right, to a certain extent, because there is some latency, or I should say slowness in the signal, right? So latency, right, for moving data. The farther away something is, the farther it has to travel. Even if it's traveling at the speed of light, it still has to get there, right, or whatever. So the farther away something is from the place where it's being used, the longer it will take to receive a response from, say, a server. But colo data centers tend to be located near the place of business, to alleviate any of that. Same with Wall Street. Wall Street plugs directly in to say an exchange so that they can be right at make the trades in the milliseconds and cut down on latency and stuff. So anyway, I'm getting on a tangent, but businesses will rent out rack space in a warehouse so that they can host many more servers, however they get those, right? So then we go to the cloud, okay? So businesses went from, our place of business, we have like 2 servers, we're good. Oh no, we need to scale up. Our application is doing really well. So they're like, well, we rent out some rack space at the colo, right? Well, I've seen cases where, at the colo where they're supposed to be handling kind of like physical security of the facility and different aspects like that, your data backups sometimes, things like that. And what can end up happening, and actually recently happened at my job, was there was a lapse in the backups and they couldn't find our data. So we thought we might have lost like years and years of data. And that was very scary. We found it, no worries. Well, they found it. But that kind of thing where you're relying on someone else for your backups, especially even if they are a large company, it's still pretty scary, right? Like you still want, not that you don't have control over that, but that kind of thing can happen, and that's not necessarily just for a colo. I mean, your company can do it too. But once you kind of outgrow that rack space, so putting security aside or losing our backups, maybe I'm just venting about that. But anyway, once a company grows and grows, right? Say I'm hosting a game, right? I made this mobile game or whatever game, and it's scaling massively. Like users love my game, and I can't buy hardware fast enough. And also with a game, you get spikes in traffic, right? So what happens is you get this massive spike where people are using it all at once, and then it comes back down, and then all at once, right? So it's very intermittent and weird, right? So it's hard to forecast your servers that you'll need, right? It's hard to know how much compute power, memory, storage you're going to need for your users. And what happens is usually companies would over-order, right? Because they want to make room for burst capacity, burst meaning traffic spikes, right? Well, when there's not a traffic spike, there's a lot of unused, right, space and a lot of unused compute, and that's dollars wasted. Okay, so what the cloud is, right? Let's start there. The cloud is actually a bunch of data centers located around the world, really at this point, right? Around the world that let you essentially use their hardware, right? And everything's virtualized, but use their hardware for things of that nature. So we need to scale up now. Like we don't have time to order servers and bring them in and then use that. No, we need it now, right? So what the cloud allows you to do is actually spin up virtual machines, containers, whatever, but compute resources based on current utilization or whatever your metrics may be. And that saves companies money because they're like, we're only experiencing bursts now, we need it. And then once it's over, they can scale it back down, which will save them that excess compute. Now, the question is where did this excess compute come from? Like, where did these worldwide data centers come from, right? And what this actually stems from is that idea of excess capacity, right? Excess compute, excess storage. Amazon had, and there were several companies before this, but Amazon was the one with, AWS and so forth, that paved the way. Amazon said, hey, we have all this extra stuff we're not using, right? We have all of these servers. They had what we were just talking about, a bunch of servers, but on a massive scale. And they were like, a lot of this isn't being used, or some percentage isn't being used at any given moment. But we want to make money off of that because we do need these servers. We're just not using them all the time. And so what they started doing was kind of renting out space, right? They're like, use some of our compute. And at the time, virtual machines were mainly the thing. So they're like, spin up your VMs, right? Which are just virtualized computers. And they're like, spin up these VMs on our hardware. And you can use as much as you want for as long as you want, and you just pay us by the use. You know, you just use it, you pay for what you use, and then you can kill it all, and we'll stop charging you. And companies are like, whoa, that's really great, because now we're saving tons and tons of money on these hardware costs, right? And that's also capitalization, right? Like your hardware, the price of it deteriorates over time. So not only do you have excess capacity, but you're losing money on your capital, right? And these are some finance kind of stuff. But nevertheless, so all of this kind of stuff is happening, and companies definitely take advantage. It takes off, right? Microsoft was a second, Google came third. Google's first actual cloud offering was this thing called App Engine. That's the OG of Google Cloud. It started all Google Cloud platform. And they've kind of scaled up from there. And we'll actually go over what App Engine is later on. But so we have the cloud. Now, this is what, say, one of those data centers looks like. Okay, so you see here, you have 3 massive buildings, right? These are, and they look maybe not massive to you because you're like, well, I'm way up above, but we can actually go in and we can take a closer look. So let's do that. And I'm gonna copy and paste this into messaging because this is a really cool way and it's interactive, and I want you guys to be able to play with it and not have to go dig it up because it's kind of a pain to find, but it's super cool. That with Google, so we're going to be talking about Google Cloud. This applies to Azure. It applies to AWS. There are some slight differences, and maybe I'll go over those along the way. But nevertheless, you can kind of expect that this is what AWS and Azure are doing as well, right? So Google Cloud's global network spans 22 regions. Okay, so regions are large geographical areas or geographic areas, right, around the world. So you have a region in US Central 1, which is kind of Ohio, right? US West, which is here in Oregon, actually out in the Dalles. That's US West 1, excuse me. And so you have kind of these, and you also have like Tokyo, you have, is it Mumbai, something like that. So all over the world, and they're always building new regions, right? They're looking to expand that a bit. But what a region is it encompasses those data centers that you saw earlier. There's 67 zones, so you can expect at least 3 zones per region, right? And 140 points of presence and 96 CDN edge nodes. And we'll talk about points of presence and CDN edge nodes in just a moment. So here we have a view of what Google's global network looks like. So you see all those little dots kind of moving around. Hopefully you see that. And you see all these regions. There's Mumbai, Singapore, Frankfurt, Zurich. Here's our US West over in, sorry, I said Ohio, I'm in Iowa, US West 1. You have one down here in Sao Paulo. So all of these different places, here's Australia, all of these different places around the world. And these lines are actually fiber optic cables that Google has laid across the entire world to connect all of these locations, okay? So these are submarine cables, and they're huge, and it's crazy to go look at the videos of them like repairing these things or laying these things. Is nuts. But what this actually equates to is something Google has that other cloud networks might not have. And they have I think they have the fastest and largest global network, right, in the entire, out of all the cloud providers, right? So they basically have their own private internet that connects all of this stuff around the world. All right, so you have regions, so you can set yourself up in a region. They also have edge points of presence. So let's say you're hosting your app in like a, like somewhere where there's like not a region. Like say you're down here, right? But you want to be able to have, or say you have users down here, excuse me. So what you want to have happen is maybe they can't set up an entire region there, but you want a way to get your data to that user as fast as possible. The thing that this is solving is the fact that you don't have to travel across the internet, right? The public internet, for 2 reasons. One, it's more secure, right? Because you're on a private network. 2, you can actually, you're not competing with all the other traffic. So there's less hops, and hops are like where your data has to travel in order to get from point A to point B. right? So when you're on Google's fiber optic network, it's much faster to get from one place to another, or get your data, I should say, from one place to another. So if I have users down here in, what is that, Chile, right? Like if I'm in Santiago and I'm up here in Oregon, but I'm hosting my app and I have users down here, there's things called points of presence. And what points of presence are actually entries into the Google network. So even if you don't have a region where you can host people, right, or host your app close to your users, like there's no data center here necessarily, but there's an entry point, like a gateway into Google's private network. So I can just say host in Sao Paulo, right? Their traffic would enter through in Santiago and travel along these over to Sao Paulo really fast, much faster than they would across the public internet to reach Sao Paulo, where my app is being hosted. Okay, so our compute lives in Sao Paulo, but the user is in Santiago. That makes sense. If it doesn't, it'll explain it much, much better than I am, and probably in more depth. But nevertheless, hopefully that makes sense. The CDN points of presence, right? Those CDN points of presence, those are caching points of presence, okay? So like if I have my app anywhere in the world, really, but let's say now we're up here in Bogota, Colombia, right? And let's say my users are using my app there, and they request, say a user requests, something from my app, and they get it, and like a web application, right? Well, the page loads for them. Well, now you don't want the next user who accesses your page to have to load that content, right? And so what happens is there's a caching, there's a CDN, right, which is essentially a place where you can use Google's caching system to cache your data there. So the next person who accesses it doesn't need it to travel from Miami all the way down to Bogota, right? It's sitting in Bogota. So when they access it, it goes much faster for users down the road or users accessing the same data again, right? And it lives there for a determined amount of time. It's adjustable, but that's also that. So those are kind of all the components that go into Google's cloud. And again, these are commonalities across all Google cloud platforms. Okay. And when I say the cloud isn't just these cloud platforms. I'm only talking about these because they're huge and exciting and mostly what people are talking about. But like I said, there's SaaS offerings, right? And there's also smaller cloud platforms like oh gosh, what's it called? Help me out, guys. So like Heroku. If you want to host your app on Heroku or something like that, right? Like you're hosting it in the cloud, it's just on a much smaller scale than what you might see here, and it's different, right? This has more than just host your app, right? It has all sorts of fun things involved, and we'll go over what those are later when we talk about certifications. So what we can do is actually zoom in. So we'll click check out a data center, right? And here you have a data center. I'm actually hearing, you probably can't hear it, but they have like birds and stuff chirping. Here you see, here's their windmills because they're all carbon neutral now and all that. I don't know, whatever. And not saying that I don't support that, by the way, not that I'm like, oh, environmentalism, but more so I don't know if I 100% trust that they're like carbon neutral or carbon negative and all this stuff. It depends on how they're accounting for that. So anyway, that's another conversation. We can look at, so one of these buildings accounts for a zone, right? So I said we have at least three zones per region, right? And what does that mean? What's a zone? A zone is an isolated place, right? So here, here, and here. Each zone, what this is meant to be is make your applications or whatever you're hosting in the cloud fault tolerant. Okay, so if like this data center burns down, right? If this data center burns down within this region, let's say this is A, B, C. If A burns down, you want to be able to fail over somewhere, and the closest place to fail over would be B, right? If B burns down, the closest place to fail over would be C. If C burns down, then you want to fail over to the next closest region. So it could be the case if you're hosting a global application, you would be not only are you hosting it, can it be hosted in multiple zones, but also multiple regions, right? And all of this is so that you don't have downtime, right? But you also want to create the lowest latency possible for your users. Okay, and it that bleeds into SLAs you might be offering or whatever. Those are service level agreements. So you say our uptime is 99 point blah 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 blah, and you can say that because you know, okay, we're hosting in 3 zones in each zone, and then we're also hosting in like 3 regions around the world or something like that, right? So the whole point is you always want to be as close to your users as possible, and so they have, you know, everything here, all their fiber optic cables come in, you can see those are underground, and then we can get closer, right? So here's your data center here, right? So you see these rows and rows and rows of servers, and this might be multiple levels, right? This is showing 1 level here, but this could be, you know, several stories tall, all the same, right? All servers and everything. And you can really explore this kind of stuff. Like you can go check out like the networking room and like all this stuff. So I encourage you to go scope this out, and check out what it looks like inside of these data centers. Poke around. It does help to visualize this when you're actually doing cloud stuff, right? I visualize this animation when I do stuff many times. So. Yeah, and there's lots more to be done inside of this. It's very, very cool. I think it's cool that Google did that for educational purposes. Okay, before I touch on this, are there any questions? I guess I'll just stop and make sure that we're all kind of on the same page. Is this all making sense so far? And I'll take silence as it is. Unless anybody has any questions. All right, I think we're oh, makes sense. Okay, cool. So this is a YouTube video. I will also drop the link for this. I think I can copy video URL. Okay, this might work. I don't know if it will copy the URL. There we go. All right, so this is another one. This is a 360-degree kind of video, right, where you can poke around. And I'm actually going to turn sound off because you know the sound. But I just want to quickly you can watch the whole video. It shows a tour. If you have your like 3D goggles, kind of cool to like look around, right? So what they do is they give you a tour. So this is the outside of the data center. So already you have these security checkpoints, even just to get into the data center, right? So physical security is something you can expect from Google, right? And Google also runs on Google Cloud, right? So you're getting the same security that Google offers itself, right? Which is very good. So here we are inside the data center. You can see multiple stories, right? And I don't know what those are necessarily, but I'm sure it explains in the video. And so looking out, right, several stories, and also usually in the middle of nowhere and close to a water source, okay? Because it takes a lot of water to cool these places off, which is why carbon neutral is kind of a weird thing, because like, okay, you're carbon neutral, but you're also sucking up water sources. So I don't know. Anyway, so we can go into here. There we go. All right, this is the view of this is just one floor, okay? All of these, each one of these blinking lights, let's see if we can get a closer look. Each one of these, 1, 2, 3, 4, 5, blah, 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 like something like maybe 12 to 15 servers per rack, right? And those go on for this entire building, this entire floor, and then it looked like about 3 stories high, right? So these are all servers. This is all compute that you yourself can go on and use. And this is to whatever memory or specifications, memory, compute, or storage specifications that you desire. It does cost money, it's per use, but again, we talked about why you might want to do that, right? And so notice this creepy security guard lurking over here. Again, that physical security aspect of things. And they just kind of tour the facility. They show the cooling pipes. This is a classic picture here of all the cooling pipes. I mean, this is actually a video, but you know, a lot of this is water being pumped around to cool everything off. And so definitely go and watch this video. Very cool video. Nice to be able to visualize what we're talking about when we talk about zones and regions and data centers and all that kind of stuff. Okay, so like I've mentioned, right, we have 3 public cloud platforms, 3 big ones, right? We have Google Cloud, we have Microsoft Azure, and we have Amazon Web Services, so AWS for those that want to know. And so AWS is the biggest. They also had first mover advantage, right? Which they call it an advantage, but it might not be in the long run. And I can explain that in a minute. But Microsoft is second, and I'm talking about users, right? So number of users or usage, I should say, of their services. Okay, so they estimate the total cloud market, and then they estimate how many users that Microsoft has, AWS has. So Google is third. Google is the third mover in the cloud platform wars, right? But again, I don't think that's necessarily a bad thing, because what AWS did was they said, here's some compute. And then users said, hey, we could really use this thing. And AWS is like, we'll give you that thing. And they just put it up, right? And it slowly grew into this like monolithic, like crazy thing that became kind of not as cohesive, right? Like different services are used different ways. The documentation's a little confusing on how to maybe integrate some of these services around their platform. And they've worked very, very hard to kind of decrease that complexity and decrease that confusion for their users. But overall, if you go to AWS or Microsoft Azure for that matter, I think Azure does a little bit of a better job. But overall, those first movers are actually very, it can be very complex. And a lot of people who start there, they don't know any different. So they're kind of like, okay, whatever. I've used both AWS and Google Cloud. And my opinion is that Google does a much better job on their cloud platform than AWS. One of those reasons, and for those that are a little more technically, have a little more technical knowledge, is that Google automatically configures a virtual private cloud for you. And what that means is it carves out when you start your account, you automatically get a network, all the networking's configured for you. Everything's kind of built up for you to begin building stuff. And what that means is you don't need networking knowledge to be able to start things, right? And that's really nice, right? That they kind of do that for you. Because if I'm an application developer, I'm not a networking engineer, or even if I just don't know about networking that much and I don't really trust myself, it kind of alleviates some of the overhead of getting started, right? That's one reason. The other reason was the global network. Google Cloud has this global network they've configured. But in terms of the usability of their platform, and I'm not promoting, I mean, use whatever, it doesn't really matter. I'm just giving you my opinion. This is not me promoting Google in any way. I'm just saying that their platform, in my opinion, they've done a very good job at making everything really cohesive. And what I mean by that is that everything on Google Cloud is an API, which means it accepts REST commands, right? So update, get, delete, things like that. And all of their APIs are very similar. So when a new technology, if I need to use something on Google Cloud, I kind of, if I've used anything else on Google Cloud, I kind of already know how to use it. It's already like, I know what to expect, right? And that's really helpful when you're trying to build applications quickly and trying to learn technologies quickly. If you don't have to worry about just how do I use it, right, in general, right? Like maybe the specific technology you have to learn, but in general, I don't want to have to learn the API. I want to be able to learn that once and then understand how Google structures their stuff and then just use whatever I need to get the job done. And I think that's Google's really strong point. And so I tend to use Google Cloud for all of my stuff. I used AWS a little bit and used it at a job, and I just, it was very convoluted for me. I don't know. Some people love it. I'm sure someone could argue point, you know, again, just an opinion. So going off, piggybacking off of Google Cloud, right? What we have on these cloud platforms is interesting, right? So on the left side of the spectrum, what we have is something called compute engine. And this is where you can spin up VMs, right? Virtual machines, again, just virtual computers. It's an operating system. You can have some persistent storage attached to it, like that kind of stuff. And all of this is software, right, that is living on the, if you've ever used anything like VirtualBox or anything, right, it's all it's doing is sanctioning off resources for you to use on a physical machine. Those physical machines are the physical machines we just saw inside of those data centers, okay? So we're spinning up virtual machines. We can add a persistent disk, yada, yada, yada. And we can get it as big as we need it to get the job done, or spin up as many as we need to get the job done, which is usually what people are looking for, is scaling out more virtual machines, not up, making your virtual machine larger. It's preferred to have a bunch of smaller virtual machines than one large one. But anyway, So on this side, though, what we have is that it's minimally managed. What does that mean? It means Google doesn't take care of stuff for you. So it means you need to configure networking. You need to configure storage. You need to configure everything having to do with your infrastructure, right? Well, that might not be feasible for folks. Like some folks don't have that knowledge. People want to get up and running quickly, right? I have an app idea. It's going to make $1 billion. I need to get it up now. I don't have time to learn networking. I can't hire a network engineer. And so this is not a side that people tend to want to be on who are trying to accomplish those things or don't have the knowledge to spin those things up. So on the other side, what we have are things like Firebase. This is Cloud Functions, App Engine, which I mentioned. These are highly managed. Okay, what's highly managed? Highly managed means Google handles a lot of the infrastructure, if not all of the infrastructure for you. So all you have to do is put your code there, right? Say we're writing Python applications. You put your Python code in, say, like a Cloud Function, right? For those who are AWS folks, that would be the same as like a Lambda function. So you put your stuff in Google Cloud Functions, and anytime that function gets invoked, it just runs, right? It's as if you're running the file directly. But what's actually happening is Google's provisioning a bunch of infrastructure for you, all the networking, all the scaling, everything, right? And you can configure that with configuration files, but you don't directly have to manage networking, like IP tables, routing, like all that stuff, right? That happens under the covers. Google handles it for you. You don't have to worry about it. So those are more managed services. And that's one of the intriguing things about the cloud platforms, right? Is Google, and another thing that Google's making a huge push for. How many services can we offer that will be fully managed, right? Like there shouldn't be a real need for folks. And I use managed services all the time. I mean, I can set up networking and stuff. If I don't have to, I don't want to, right? Like if I don't have to, I'm not gonna. I'm always opting for the easiest solution and the quickest solution, right? And so a lot of times it's Cloud Run, App Engine, Cloud Functions. All of these are managed infrastructure for Google Cloud. Kubernetes engine falls somewhere above Compute Engine. So you do have kind of infrastructure, your nodes, where you're spinning up your Kubernetes clusters. If you don't know Kubernetes, no worries. That's going to be one of the things we cover in one of the demonstrations down the line, where we show you how to put an application on Kubernetes engine, how easy that is. Well, easy. But at any rate, we're going to... The Kubernetes engine is one of those things where, yes, you can spin up nodes. Yes, Kubernetes engine will actually launch onto those nodes, and it's kind of taken care of for you, but there are some infrastructure things that you need to do. So that's why it's on like kind of like not quite minimally managed, where, you know, GKE, you tell it, I want 3 nodes, and it'll spin up 3 virtual machines for you to put your containers on or your clusters on. But at the same time, there is a lot of management that goes into Kubernetes. So App Engine is one of those ones where you can take your application code, say a Python application, you can just say app deploy, and it just deploys, and all the networking and all the scaling and all of that stuff, that traffic spikes we were talking about earlier, it'll handle that. It'll say, oh, it looks like your utilization's up. We're going to spin some more compute up for you, or whatever, right? So anyway, hopefully that was explained well. Again, if you have any questions, feel free to jump in. So you may have already been able to kind of see it, right? We've kind of hinted at it, but what's in it for companies? Like, why would companies want to migrate from, say, an on-prem or a colo over to the cloud, like a cloud platform? Like, what's in it for them? Because it's a big job, right? Like, you have to basically lift and shift your entire operation onto something different. Like, why would you want to do that? That costs money, right? Time is money. It takes time. Possibly more personnel with the proper knowledge on how to do that, or hiring an outside consultant to come and do that. So why are we doing this? Benefits for companies, right? Well, you only pay for what you use. So for companies, like I said, in forecasting, it can smooth out their forecasts a little bit, or at least save them money. Maybe not smooth out their forecast, but save them money in the long run. And they can allocate that money towards other things that, will grow the company and bring in more business and so on and so forth. So better security, right? Like, so, I don't want to bash on security people, right? Because they do an amazing job. But when you have a company, and say you have your servers on-prem, even in a colo, right? You probably have mid-sized company, like a handful of security people, you know, like on your team, and that can be that's good, but at the same time, like there's a lot of errors that can happen there, right? Like, and the professional expertise might not be as high as it will be from someone like Google, where they have an army of security people constantly looking out for these cloud platforms, or Microsoft or whoever, right? An army of security people doing top-notch security research and are, you know, some of the best at what they do, right? Hardening Google Cloud or AWS or whatever, hardening that, making sure that there's no vulnerabilities. When you have an army working on it, you know, that can be, they can be much more successful. And especially as a larger company, they have more resources to put towards security, right? Like sometimes security falls through the cracks. I've seen it. In fact, it happens all the time. and you know, to be able to put your trust in someone like Google, you basically get their security resources. I don't want to say for free, but at a discount, right? People who are working 24/7 on these problems, right? So really helpful. Partially and fully managed services, right? We went over those partially and fully managed services. So you can use a spectrum of different things to get the job done, which is really nice. Whereas you'll have less automated or managed services, or if any at all, if you're in a colo or on-prem. The data can be accessed and shared much easier, right? So I just put my data in the cloud, I give someone access to it, and bam, it's ready to go, right? When you have a colo data center, the permissions for setting things up, like getting people access to the data, can be tricky, right? And that's where it takes your engineers and the security people and all of these things to make sure that that's being done correctly. It's not impossible. Obviously, it's gotten done, right? But in the cloud, you can literally just manage how much access people have through IAM permissions, and that's it. And you have all kinds of storage options. You have SQL databases that scale automatically. You have you know, storage buckets where you just store vast amounts of bytes, right? Whatever you need. You also have options, and you don't have to manage those services. They're managed for you, which is really, really nice. Again, you get scalability and fault tolerance and all the goodness that comes along with Google Cloud that you wouldn't necessarily get in a data center or on-prem, especially on-prem. And then I just mentioned automatic scaling, right? So they scale the infrastructure for you. You don't have to worry about it, right? It just happens magically, call it auto-magically, which is a huge deal, by the way. Scaling is one of the hardest things to get right when it comes to building applications or software or whatever the case may be. So what's in it for me? Like as a developer, like, why do I care? Like, okay, that's great for companies, but it seems like a pain in the ass to have to learn this new thing and get ramped up on all this. I'll just do it how I normally do it. I'll just build it on my computer and then whatever, you know, like, so what's in it for me as a developer? Managed services. Those same managed services that companies can utilize to control costs and save on labor resources that would be used for, say, like scaling and networking and all of this stuff, and reallocate them towards something better, right, or more useful for the company, growing the company. You can also take advantage of that, right? So if you want people to see your application, so say, you know how you have a portfolio? Say, they're always like, get your GitHub portfolio together, you know? For me, doing hiring, right? If someone was like, I built this app, right? Okay, cool. Lots of people can build apps. There's plenty of Medium articles on how to build apps, right? But then they were like, if they took the extra step to say, and it's being hosted in a container on Cloud Run, which is essentially managed Kubernetes, right? I launched my application there. You can access it via this URL link. I'd be like, whoa, okay, that's much different than just simply I can code, right? That's an understanding of how to, at least in a very simple use case, but nevertheless, it shows that they have the ability to not only learn new technologies, but understand why kind of that's important, or how to utilize them, right? And I like that, right? That would be very cool to me, for someone to be hosting their application on, say, App Engine or something. And there's a generous free tier when it comes to that stuff. So it's very easy to stand something up and you don't pay anything, right? So that's kind of a gimme to go to a company and say, okay, first of all, I have my certification in this hand and I have my URL, go check it out. It's my application, whether it's my personal website or whatever, you can host all of that on in the cloud. And that shows that next level, right? That like kind of extra step versus someone who's just like, I have a badass GitHub repo. And it's like, do you know how to do you know your infrastructure stuff as well? Because it's becoming more and more that developers are like, you need to know your SQL databases. You need to understand like the ins and outs, and especially the cloud. That's just useful for companies. They're like, we want to hire people with the knowledge. We don't want to have to hire people, then teach them and blah, blah, blah. That's more overhead for companies. They would like to see those skills right off the bat. That's very useful to them. So managed services, utilize those because they're very, very nice for standing things up. I utilize them all the time. I need to be a hotshot networking guy standing up VMs or even Kubernetes, right? Like standing something up on Cloud Run is very cool, right? I think that would score some bonus points with me, just so you know, and I think others too. Okay, so hopefully that was a well-rounded it was a whirlwind, I know, but hopefully it was a well-rounded overview of what these cloud platforms are all about, kind of what the cloud is trying to solve in a lot of ways. I kind of specifically talk about cloud platforms, but in general, cloud has the same themes across the board, no matter what it is in terms of like scalability and fault tolerance. All that stuff goes along with any cloud offering that you're using. So, as developers, right, we're like, okay, cool. So I could utilize this by myself, but that doesn't, if I'm looking for a job in tech, right, like even if someone shows me their application on Google Cloud, that alone for me would be cool, and I'd be really excited to see that, but it wouldn't necessarily be enough to like prove to me that they know, because again, there's Medium articles, right? And I know I just said, again, it would score bonus points, and that's not what I'm saying, but I think that there also needs to be that element of a prove it, right? That's part of the prove it. And I always say in tech, it's one of those industries, pretty much like most engineering type and technical roles, there's always this prove it, right? There's no like kind of bubblegumming your way, or whatever you want to call it, right? Like fluffing your way through an interview. You either know it or you don't. And guess what? Those interviewers, they know it. And when they ask you, if you try to BS them, they're going to know, and you're not going to get the job. So this is one of those prove it industries, right? And one of those things that can prove it is a certification, okay? And a lot of certifications, I shouldn't say a lot, but there's many out there that are not really worth it, right? Like they won't help you. They don't, it'll be hard to leverage them in order to get a position anywhere, right? But these cloud certifications, these are different. And the reason they're different is the difficulty, right? So first, some stats. Okay, because everybody loves a good factoid. All right, 50% of enterprises spend more than $1.2 million on cloud services annually. Okay, any cloud services. That could be like we've talked about all kinds, right? That's a lot, right? 50%, half of all enterprises spend more than $1.2 million, more than $1.2 million on cloud services. That could be anything above that number, right? Revenue from the public cloud sector is expected to increase to $331 billion by 2022. It was $175 billion in 2018. Okay, that's what? Looks like a little more than double. No, a little less than double. A little more than double. Someone do the math. No, less than double. More than double. Someone do the math for me. I'm just gonna sit here and keep going back and forth. But it's a lot, right? And that increase of about 50%, or 100%, I should say, increase in just 3 to 4 years is just showing how much it's growing, and it's only going to grow more. because Google Cloud is expanding. Companies are moving into the cloud. Like that's going to continue to grow. And I had a graph on that. I don't know if it's on these slides, but it's you see that curve, right, starting to take off. 83% of enterprise workloads will be in the cloud by 2021. Okay, 83%. So pretty much most of them. Okay, and that's by the end of this year, right? So that shows that lots and lots of companies have realized the power of cloud platforms and are definitely pushing hard to move there. Okay. There will be 100 zettabytes of data stored in the cloud by 2025. Okay, 1 billion terabytes, 1 trillion gigabytes. Okay, a lot. The public cloud service market is expected to reach 623.3 billion by 2023 worldwide. And I don't have the numbers before that, but I mean, you can just see that it's a huge industry. Where there's money, there's people clawing to get in and make money off of it, which means they're going to be peddling more cloud services, which means companies will be buying more cloud services, which means that number is only going to go up, right? Again, for all the reasons that we've cited along the way. Okay, so the reason I say that is just showing that companies value cloud experience, okay? And because they want to get there. Most companies, when you talk to them, they're like, none of them are like, oh, I'm good. We're going to stay on-prem. We like it this way, right? Most of it is a giant headache for companies. Some of them just don't have the ability, the money, whatever the case may be, to move to the cloud if they're not there, or it's just a giant migration that needs to happen slowly. So slowly companies will begin one by one migrating their services. I've been in several companies that are doing this, including the current company I'm working for. So this is where certifications come in. So if you come to them and say, I have the Google Cloud Certified Architect exam in my back pocket, they will be like, this person knows what they're doing. They passed the test. That is huge leverage. I can tell you right now that I have gotten at least 3 jobs. A big reason was because I was Google Cloud certified. Like that, it carries more weight than a awesome GitHub. Like it's so valuable for companies. It's crazy, and you can see by these are average salaries, so take them with a grain of salt, okay? But 175,000 is the highest average salary for any certification in the United States. It's higher than the PMP, the project management certification. It's higher than anything, okay? That's how valuable people think these certifications are. And second, not in the US, but just in these cloud certifications, is the Solutions Architect Associate. Okay, that's not even the top tier. That's an associate, right? The AWS one, right? Definitely, David. All right, see ya. And so that surprised me. I was like, geez, like the cloud associate for Google Cloud is okay, but they might not even like care as much that you have that. But this solutions architect associate, that's awesome. Like that's very valuable for folks. And then the cloud practitioner, that's their, I believe it's their entry level certification. And that one's 131. Microsoft Azure Fundamentals, also entry level, 126. And then the Azure Administrator Associate, 125. And that's a cloud administrator, lots of networking knowledge and things like that come into play for that one. Okay, these certifications differ in a number of different ways besides their salaries, right? One is, I would say, difficulty. So like it's difficult to compare across clouds. Like, the solutions architect is similar to the cloud architect. That holds true. But some of the entry level ones, like the cloud practitioner, the Azure Fundamentals, and then there's one for Google Cloud called the Cloud Engineer Associate, I think. Those are more difficult to compare. One, because I haven't taken all the tests, but two, I did take the cloud practitioner, and I thought it was a little bit harder than the cloud associate for Google, But then I took the cloud architect, and that was so hard that I can't imagine that AWS would be any harder than that, unless they're just going over so many. It could be the number of technologies they cover or whatever would be the only difference, I would say. But let's see, Christina says, I have my Azure fundamentals, but no one seemed interested in it so far. I need something less basic, I think. Yeah, and that's the thing, is those entry level certificates are good for two things, in my opinion. One is for getting a feel for the test and kind of how, you're dipping your toes into the waters of the cloud and that kind of thing. The other thing is a confidence builder. Once you pass that test, you're like, okay, I can do this, right? Before you're like, oh, I don't know. And so just building that confidence to be able to continue moving up, right? But in terms of the job, right? Yeah, but in terms of a job, yeah, they're going to expect something larger, right? And like I said, I mean, you can see the solutions architect associate, it's not even their top tier, and yet it is still considered, it's highly coveted. So, you don't have to be a full-on architect or whatever for it to make a difference in your job search. All right, so saw the salaries, right? You're like, wow, how do I get in on that, right? Remember, they're averages, so don't get too crazy, but take it with a grain of salt. But how do you get certified? Okay, there's several resources. These are the resources that I recommend for getting certified. The first one is Quick Labs. Quick Labs is a website, and they may have changed the name of it. I think it's still Quick Labs. But Quick Labs, and I'll copy these links for you. So Quick Labs are interactive labs that you can take. What they do is they spin up a sort of an isolated environment for you to, yes, O'Reilly is the bomb. Okay, we'll get there. I love it. Quick Labs is, they spin up isolated cloud environments. So they have a scenario like, how do you launch an application? Or how do you network VMs? Or like whatever, right? Whatever the case may be. It's isolated cloud. So you can do the lab and make mistakes, and you don't get charged for any of the cloud resources, right? You just pay like a subscription, or you pay, for some tokens to use on their website. And then you can go through all these scenarios and get hands-on cloud experience without having to fork over money, potentially hundreds of dollars if you make a fatal mistake on the cloud. Now, I will say that all the cloud services offer a free tier as well as credits when you first start. So I know Google offers like $300 in Google Cloud credits, which is plenty to get started as long as you're controlling your resource usage and all of that stuff. But I like Quick Labs because it sets up like an environment where like you're going to launch an application. Maybe they've already configured some things in the background for you, so you can hit the ground running rather than having to like do that stuff yourself. So it just depends, right? But I like Quick Labs for that, just learning new things and without having to worry about cost and things like that. Best courses used to be Linux Academy. Linux Academy recently got bought by a cloud guru. A cloud guru does a really, really good job of giving you kind of study or teaching. I don't want to say teaching to the test, but they definitely cover everything you're going to need on the test. And they also have a test bank. So when you're done with your course, you can go into the test bank, right? And you basically go take a dummy test, right? And these tests, the Google Cloud ones were 50 questions, and you get like 2 hours, I think, to finish. But a cloud guru offers a test bank of kind of model questions that you might see on a test, right? And they also have AWS, they also have Microsoft. Same with Quick Labs, they have AWS, they have Microsoft. And of course Google Cloud. But that's a great online course to take they're for specific certifications. And they also offer Kubernetes training. They also offer networking. They offer all this other stuff if you're also wanting to get into that security and all kinds of stuff. And they teach for all the certifications. I think they cover them all. The best books. So O'Reilly I didn't know about it for a really long time, and I really regret that because it is amazing. So O'Reilly, you might know their books, right? The O'Reilly books. They're really good. But beyond just books, O'Reilly also has things like interactive scenarios. So they bought a company called Catacoda, which gives you sandbox environments. Wow. Okay. I don't know why that link was so long, but they give you sandbox environments, right? Where you can, they give you like a Kubernetes cluster. You can just play on this Kubernetes cluster, or they'll give you scenario-based environments. Kind of same for as Quick Labs, very similar for all sorts of things as well. But they also offer books, and not just O'Reilly books, books from Manning, books from Packet, books from all the publishers, right? So you can get all these books for like, it's $50 a month or $400 a year. And for me, that's a steal. And Christina just popped in and mentioned another one is the tutorials or the live events, right? They have conferences, they have convention, sort of convention-y type things where like they had one recently on scaling your artificial intelligence applications and things like that. And they have experts come in and give talks during those. They also have very targeted ones like, get your CISP certification or whatever the case may be, right? It's like a 4-hour course from a professional that will show you how to do that or how to use Kubernetes or nice. Yeah, exactly. So they'll break it up into a series. So right now, Christina said she's taking one on Ansible, right? And so they're very, very targeted ones, and those are really, really nice too. Though, but someone like how to use pandas for financial data, or like all kinds of stuff. It's really, really cool. But you learn from experts, and that's all included in that $50 a month. It's crazy. It's like a steal. I don't know how they do it. Anyway, love O'Reilly, absolutely a resource. If you're paying for anything, definitely a resource that you should pay monthly for. Honestly, I would probably take that over Coursera or any of those things, just because there's so many resources on there that you can just utilize that's included with your subscription that it's hard to beat. Hard to beat. Unless you're, even if you're not a book person, like I said, those live events are crazy. Okay, cool. Well, Richard had good timing because we're right at the end. So, this is the kickoff to our I'm going to say 3-part series. One of, I think the GK, we might break it up into 2. I haven't decided yet. I don't know if I want to shove Kubernetes down your throat in an hour, but we'll see. We'll see how that goes. But hopefully you learned like a lot more about the cloud if you were kind of fuzzy on what it was or how it works or why people use it. I covered a lot of stuff over this past hour. I don't even know what time it is. 6:10. Yeah, actually not bad. About an hour. So are there any questions covering anything that we talked about, from data centers all the way to certifications or anything like that? I'd be happy to answer anything you guys got. Feel free to just jump in, by the way. Yeah, Christina.
Yes, hi. I'm not sure if it's a good question or not, or if you have an answer for me, but last year when I was job hunting intensely, I put my little resume and the little app I made up on Azure, and
Nice.
then I started looking into Azure, and then I started actually learning more. And I'm probably not the first person who realized that, oh my goodness, there's no security whatsoever, because apparently that was supposed to be my job and I didn't know how to do it yet. So what would be your recommendation for someone who, as you said, is new and wants to just show that they can use it? How would you show that you know how to use it responsibly?
That is an excellent question. Let's see. If I was going to show off that skill set, right? Like I said, in the cloud, you're using what are called and I'm not trying to explain it to you, like you probably know, but use IAM permissions for all of those that don't know. Identity access management, right? And what that means is you're granting access to certain resources on the cloud, right? For people to be able to do things in the cloud, whether it's accessing data or using your application or whatever the case may be, right? If I was wondering about that, what I might do is maybe put it like you're storing your code in a source repository, right? Like so in a GitHub repository or whatever. In your README, you could explain kind of your reasoning behind, and it doesn't. I definitely don't suggest like posting your config files or anything, because that would show me that you are not a security-minded person. But nevertheless, I would give maybe a short explanation on your security best practices that say you used, right? So whether that's, I'm using, explain you're using TLS certificates or using, an Nginx server in front to handle termination or whatever the case may be, right? Like explaining that somewhere on the GitHub repo or even on your website that is being hosted. You can say this website is hosted using, security best practices, blah, 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 blah. Something like that, right? Like just somewhere just explaining that, hey, I didn't just put this here. This is actually a secure thing. And they should know if you're using like HTTPS, that would be a surefire way to know that, oh, they've configured, SSL certificates or TLS certificates for this website. Good question, really good question. Yeah, that's
Cool.
that's a
Thank
tough.
you.
Yeah, totally, absolutely. Daniel. Daniel again.
Oh yeah, what I was just going to say, what's really particularly nice about the Google Cloud Platform, and one of the reasons that it ended up being our choice was that they're explicit about their data is encrypted when it's at rest and when it's in motion. So if you're configuring your project within the confines of your Google network, you just have this amazing levels of security that you, as Chris was pointing out, you're kind of part of your monthly fee is to maintain that little army of mercenaries that are looking out for your best interests.
Totally. And that's a really good point. It actually didn't used to be like that. They only said data was encrypted at rest. And it was only recently within the past couple of years that they said, oh yeah, and on the go too. So yeah, that's actually something newer and really exciting because now you don't have to worry about it, right? Especially for things like I was saying earlier, like healthcare applications and stuff. It's really nice when you're dealing with data that can't fall into the wrong hands, let's say. So yeah, great points. Yeah, thanks for bringing that up. Any other questions I can answer for folks before we wrap up here?
I was going to say one more thing too, Chris. One thing I really appreciated about Google is, and I'm only scratching the surface. I'm just using basic App Engine. I'm not doing anything really sophisticated. But what I really like about them is if you get a traffic burst, they will ramp up your service pretty damn instantly within a matter of seconds. But the great thing about it is that when your traffic burst passes, they will ramp it back down. And Amazon doesn't do that, or at least they didn't when I was investigating services. And you wind up with this big ass bill, and you go, "Oh my God, what happened?" But the only thing you need to be careful about with GCP is that if let's say you go and deploy, 20 different instances because you're trying to rapidly iterate through a series of problems, you need to go back and police your instances so that you only have one active running, so you don't get caught with an unexpected bill.
Yes, yeah, so important, and that's one thing, and that's another thing that falls on you, right? Security is one of those things that I said falls on you, although Google handles a lot of stuff, which is really, really nice. The other thing that falls on you is controlling costs, but they do have a really nice feature of their billing platform is really, really nice in the way that you can configure it to give you alerts and things when your resource usage starts to pass a certain threshold, right? So say I've spun up a bunch of VMs, I forgot about them, and they're just running. Well, I can configure to get text messages, emails, whatever the case may be, that says, "Yo, you're using a lot of resources," and you can go and destroy those. One thing I like to do when I'm working on the cloud is to create lots of scripts. So they have all the cloud platforms have it, but they'll have an SDK, right? And you can install that locally on your computer. it's also available to use in the cloud. And what I'll do is I'll actually create sorry, I was getting ready. What I'll do is create scripts, right? So I'll make a script that gets rid of, say, VM instances, right? And I'll have maybe some inputs where I can put the name of the VM instance, and then it goes and deletes it. So I don't always have to type that command. I just run the script, and I know that that was taken care of for me. So I you know, when I'm developing, I'll just continue to build these scripts, and before long, I just have, and you can do it with Python or whatever you want to do, but I tend to use Bash and for this kind of stuff, and it's really, really nice for either spinning stuff up, right? So creating resources, which you can also do from there, but you can also delete or update or whatever the case may be. So building out scripts for that kind of stuff and scripting it can be really useful, and they build their SDK in such a way that they promote that, right? They want that. They want folks to do that. So that's really important to.
And then I was going to say one last thing, and I swear I'll stop. The other thing that's really awesome about the GCP is that if you put up an upgrade, they allow you to really, really gracefully fall back, and also to split your traffic, so that if you just wanted to see before your new thing broke everything in the universe, you could like route 5% of your traffic over to the new thing and still keep. Because I see people, look, their site goes down when they roll out the new feature, and I go, boy, they really could have used that rollback.
Yeah, and that's big too. Remember, we were talking about not only the scaling up and scaling out and all that kind of stuff, the networking, but when you're iterating, especially if in a situation maybe where you have a very agile environment and you're working in microservices, and people, and maybe your DevOps is really mature and they're deploying things all the time, like your developers are just constantly like pushing and deploying and pushing and deploying. These microservices are getting deployed. You need a way to quickly and easily roll that back if it breaks, right? Like say it passes your test, but once it goes into production, something goes haywire. You want to quickly, like Dana was saying, roll back. And the cloud allows you to do that. On-prem, that might not be as easy, because once you overwrite your database, you need a way to unroll your database. And that can be a really big headache. I've seen some, 12-hour deployments because of things going wrong, right? Like, and I'm sure other people who have been in the industry have sat in on those really fun sessions as well, where everybody's just crying and sweating. It's not, it's great. Yeah, no, Daniel. So just so everyone, Daniel was asking at one point about App Engine, and we kind of went back and forth, and he's been successfully able to, with not a strong like cloud background, like been able to stand up a pretty sophisticated application, which is really, really awesome. And not to say, downplay any of Daniel's knowledge or anything. He was just getting into the cloud just like everybody else, right? And was just curious how best to like do that kind of stuff, and he's built something really, really awesome, which I hope he presents one day. But nevertheless, yeah. So it is a learning process. Don't expect to just be able to walk in and just own it unless you have a lot of experience in tech and being a developer or some sort of solutions architect or something like that. But it's worth it, right? In the end. All right, Daniel, thank you. So with that, I put it out for any more questions anybody has. I'd be happy to answer before we wrap up our session. Awesome. Well, thank you everybody for sticking around. Thanks for coming. I hope this was useful for you, and I hope you will continue your journey into the cloud, and hopefully we can kick that off for you by showing you some of the different ways to take a relatively simple Python application. We'll be taking a Flask application, and we'll be showing you different ways to put that up in the cloud and begin utilizing those resources for either your project or at work, or if you're wanting to go on and get certified, which I hope you do, pretty well on your way to doing that. So with that, we can wrap it up, and everybody have a great night. Cool. Thanks, everybody.